Chose to do German Shepherds as my eukaryotic organism. The three loci that I chose to do are fur color, with black and tan being dominant over just black, eye color with brown eyes being dominant over blue eyes, and hair length of short hair being dominant over long hair. As you can see, these are the two original parents. One parent had blue eyes, black and tan coat with short hair, and this parent had brown eyes, black hair, and long hair. So together they made a black and tan, brown-eyed, short-haired. So this comes over, and so does this. Now you will take the same example from the last one and do a trihybrid times a test cross that is all recessive. This is to determine your gene order. As you can see, the no cross is going to be straight across. So you will have the lowercase e, capital F, capital H. So then you will take these and you will circle the lowercase e, capital F, and capital H, and that one by itself will determine where the locus will be. So E locus has to be in the middle because it's by itself. So this is the correct way to write the map. As you can tell, the E is in the middle where it's supposed to be, and these follow. So down here, this shows how to get SCO1 with the crossover in the first division, and this shows how to get SCO2 in the second division. So now that we have determined which ones are DCOs, which ones are SCO1s, which ones are SCO2s, and which ones are NCOs, I am able to put them in a chart so that you can tell the different possibilities of each of these, along with their observed numbers, what they're crossed with, and their F1 gamete. Finally, we are able to discuss our map. So here is our final map. This is the one that we're going to show in the example. So to get to this number, you're going to do SCO1 plus DCOs divided by the total number times 100. So we did 5 plus 8 for the DCOs. Then we did 10 plus 15 for the SCO1s. And then we divided that by the total amount and then multiplied it by 100, and you got that number. That is where you got your value.